Good morning. This is Unit 1, Day 8. This is modeling with functions. First, we're going to talk about direct variation, and then we'll go to inverse variation. Two linear models where y is directly proportionate to x. So if we have something like this, y equals mx plus b, this is a straight line. The y-intercept is going to be when x is 0 and when whatever b is, so 0b. If we have something like y equals, direct variation would be something like kt, this is what we learned in algebra, or kx, whose y-intercept is, if I substitute 0 in for x, anything times 0 is 0, so it'll be 0, 0. A practical example for direct variation would be something like earnings for hours worked. So how much would you earn if you work 5 hours at a constant rate? Inverse variation is when y is inversely proportionate to x for some constant k. So if they say something like xy equals k, days to build a house decreases as workers increase. Something like y equals, if I just divide each side by x, it'll be k over x. Okay. Joint variation might be a little new. Two different direct variables in the same statement. So we have something like z. If z varies jointly as x and y, then z equals k times x and y for some constant k. An example would be interest earned varies jointly with the principal and time. So if this is principal and time, this with k will be your interest earned. Now, if we're asked to write a function from a formula, I'm just going to do a couple of these. For example 1, it says the perimeter of a rectangular garden is 84 feet. This is important. A rectangle, we know, is like length times height, but the perimeter is 2 times your length plus 2 times your width. I'm going to say width. Express it as an area. Express its area as a function of the width of a side. So I know that the perimeter is 84 feet. What I'm going to do is just substitute that in for this. 84 equals 2 times length plus 2 times your width. Now, what I want to do, since there's only one other variable, I'm trying to express this as a function of w. So I'm actually going to try to solve for L. And this is what I'm going to show you. I have 84 equals, I can factor out a 2 here, times your length plus width. Divide both sides by 2. I won't skip these steps so you can see what I'm doing. Divide both sides by 2. 84 divided by 2 is 42. 2 divided by 2 is 1. That's why we do it, to get rid of it. Equals your length plus your width. So I'm trying to solve for L. My length equals, if I subtract your W on both sides, 42 minus W. Now we're not done yet. We're trying to express the area as a function of width. So my area, the formula for an area of a rectangle is length times width. We multiply them together. But I know what my length is. It's 42 minus W. So my area equals, my length is 42 minus W times your W. Which you can simplify that if you would like to. That's all I'm going to do. So this one says the volume of a right circular cone. Don't worry about that word right. All we know is that it's a cone. Is 1/3 pi r squared h. If the height is twice the radius, so my height is 2 times my radius. This is very important. Express the volume, this is the formula for volume, as a function of the radius. Well, my volume equals 1/3 pi r squared times your height. But my height equals 2 times your radius. So I'm just going to substitute that in. 2 times your radius. I can actually simplify this. Bring the 2 out in front. I don't have any exponents or anything to multiply it by. So v equals 2 over 3. Still pi. And now I'm multiplying r. I have r squared and then r, so that's r cubed. That's it. Find the volume of a paper snow cone cup whose radius is 2 inches. So if we use this formula, assuming that we still have, the height is twice the radius, my volume, when my radius is 2 inches, is still 2 over 3. Pi is not a variable. This is a number. 3.14159 keeps on going forever. And then my radius, it says, is 2 inches cubed. 2 cubed is 8 times 2 out here is 16. So we have 16 pi over 3. And this is as far as I can go without estimating. So after I plug this into my calculator, I get about. So these mean about 16.76. And I'm in inches, so IN. Volume is in the third dimension, so this is cubed, inches cubed. Check my work, make sure I'm correct. Now finding the distance from the origin. First, I'm going to write down the distance formula, what we learned maybe in like Algebra 1 or Geometry. The distance equals the square root of, and then we say x minus x squared plus, and then y minus y quantity squared. Okay. Now, in this case, we have this parabola. I encourage you to pause the video and actually read this question. And we want the distance from this point, which we don't actually know where it is. It's between 1 and 2, and my y value is in between 1 and 2, closer to 1. And then this point 0, 0, which is called the origin. 0, 0 is the origin. What is this distance right here? What we're going to do is we're going to use the distance formula, express the distance from P to the origin as a function of x. So we have, just remember that y equals, this function is y equals x squared minus 1. And then I'm going to just write down this formula as much as I can, substitute in the things I know. I know this is the square root of x minus the origin is 0, the x value is 0, squared plus this value is just y, we don't know what it is, minus this y value is 0. Okay, so not too bad. Y minus 0 is just y, x minus 0 is just x, we still have to square it, so I have the square root of x squared plus y squared. Now, we're not done. They want it as a function of x, and we have a y in here, so it's not a function of x yet, but I know what y equals. Y equals x squared minus 1. So I can substitute this in now. What I'm going to do is underline it and then show you when I do this. I'm going to do it now. So my distance equals the square root of x squared plus, now remember to use your parentheses, this is going to be x squared minus 1 squared. And in order to figure this out, you're going to have to FOIL it. So x squared minus 1 times x squared minus 1, whenever we have a binomial, we have to FOIL that. So this gives us x squared plus x to the 4th, and then minus x squared, so minus 2x squared, and then plus 1. That's what you'll get, hopefully. And if I simplify this, I'm going to get x to the 4th minus x squared. Negative 2 plus 1 is negative 1, and then still plus 1. Okay. That's it. This is my function, depending what x is. So part B is just a calculator question. I just want you to use your calculator. You can actually graph it and use the min function to find out what the local minimum is. Okay. This one is a little different. It's kind of like a two-part problem. It says grain is leaking through a hole in the storage bin at a constant rate of 6 cubic inches per minute. And at first, I just wanted to use this, and then the rest of the equation is in feet. So we have to make sure we're in the same units. The grain forms a cone-shaped pile on the ground below, just like this. And it grows, as it grows, the height of the cone, the height always remains equal to the radius. So H equals R. And we already kind of talked about this today. The volume of a cone, we're talking about the volume of this, is equal to 1/3 pi R squared H. But H is equal to R. So I can just make this 1/3 pi R squared times R is R cubed. Okay, we kind of talked about this. If the cone is 2 feet tall, but everything else is in inches, so I need to convert the 2 feet equals, well, there's 12 inches in a foot, so this is going to be 24 inches. And this kind of like actually would make people make mistakes, is converting to the same units. So I have my volume of the cone right now, at this moment, is 1/3 pi, I don't know, 24 cubed. I'm going to pause this and check my calculatora. I think my volume equals something like 4608 pi inches cubed. Okay, I'm not done yet. This is not it. Now, they're saying that it's going to get bigger. My rate is going to be 6 inches per minute, but they want to know after an hour, which is 60 minutes. So 6 inches times the 60 minutes, so 6 inches per minute times 60 minutes, is a 360 more cubic inches that we're going to have to add to this. So my total, I'm going to use a different color. My total height in 1 hour is going to be, I don't know, whatever, 4608 pi plus 360 pi, or 360 inches. They're both in inches now. Something like this. Okay, well, I put this into the calculator with the pi right here. Don't forget the pi. And then the 360 doesn't have a pi. And I got about 14,836.459 or 46, right? And this is inches cubed. But this is my volume. They're not really asking me for the volume. They're asking me how tall will this be. But if this is my volume, I'm just going to set it equal and find out the height. So my volume is 14,836.459 equals 1/3 and pi and R cubed. Remember, we just have to find R, 1R to find our height, because the R is equal to the height. So I have to divide by 1/3 or multiply by 3, divide by pi. And I want you guys to try this out. At the end, I took the cubed root, right? We have this cubed. We need to take the cubed root of it. So we get something like this. 24.197 inches are my height. Inches or height is in the first dimension, so I don't need like a cubed or anything over here. Check my math, make sure it's correct. All right, I'm just going to try one more problem. Let's try this one. It says find a mathematical model for the students. Boyle's law for a constant temperature. The pressure of a gas, so P, is inversely proportionate to the volume of the gas. So my pressure is equals inversely proportional to the volume. So then we're going to have a K. My K is my constant. So that's about it. I mean, Newton's law of universal gravitation, the gravitational attraction F between two objects of masses m1, m2, is proportionate to the product of the masses. So product means we're going to multiply m1 times m2. Inversely proportional means I'm going to have a division. Inversely to the square means squared. Square of the distance r between two objects, so r squared. And this is equal to F. Hooke's law for springs states that the distance a spring stretch or compress varies directly as the force on the spring, a force of 275. So varies directly means we're going to multiply. So we have, does it tell you what the thing is? Maybe D is the distance a spring is stretched, varies directly as the force of the spring. So I'm going to say this is K times the force. K is my constant times the force. Okay, now they're giving you part of this equation. It says the Newton stretches a spring, this is the distance, 0.2 meters, which is the same as 2 over 10. You can put 0.2 or 2 over 10 meters equals, I don't know what K is, but they're telling you the force, 275. Okay, find your K. Tell me what K is. And then we're going to plug it in for A, and we have our D equals whatever you found for K. And I want you to finish this problem. If you have any questions, please let me know. Have a wonderful day.